All right, folks, here we go. Level 3 and 4 on the momentum assignment. So level 3, number 1, you start off with you in a boat. And so the idea here is if you're in the boat and you have a ball in your hand, here's your boat. If you throw that ball this way, what effectively you're doing is you're creating a collision with you and the ball. So what will happen is the ball will leave your hands and shoot off this way with a new velocity that you've given it. And you and the boat will still be together, but you'll be moving hopefully a little bit this way. And that's the idea, is that you're going to develop a velocity in this way that's going to slowly drift you to the dock. And we're going to try to figure out how long it takes you to get there. So it's easy to figure out how long it'll take you, d equals vt, but because we know the distance to the dock. But we're going to have to figure out this v using momentum. And the trick here is just to keep track of which things are moving and which things aren't and where everything is. Initially, you have everything together. So the mass initially is your mass of you, plus the mass of the medicine ball, plus the mass of the boat, right? So 40, the mass of the medicine ball is 12, and the boat is 90. So that's 144, I think. 130 and 12, right? 144 kilograms is the initial mass. So when you're doing your change in momentum, this is the mass on the left side, the momentum before. But after, in fact, why don't I do that? Momentum before equals momentum after. So here we have the mass, the total mass of everything, times its velocity of 0. You're not moving, so that side of the equation becomes just a 0. But after the equation, there's a ball, the medicine ball, which I'm using an M for, that's moving one way, and then there's you and the boat combined. So this mass is you plus boat, and your velocity, u plus boat prime. You see, because you're moving together. So you'd have to put the 12 kilogram block here, and you know something about its velocity. I think you're throwing it at 4, right? Now in the picture, the 4 is to the left. You can just figure this out and you'll get a negative answer for your velocity of the boat, which just means it's going in the opposite direction that you throw. But if you prefer to look at the picture and put a -4 right here, that's fine too. That'll give you a positive velocity for the boat. So however you want to do your reference framing in your head is up to you. Okay, and of course the mass of you in the boat is 90 and 40, or 130, and then you have your VB prime, or you in the boat. And of course that's your V that you're going to be using to calculate how to get to the dock. So there, that's a little bit tricky there. Okay, number 2, the bomb. I intended to make an actual video on bomb questions because they're quite common, so I guess this will be it. Here you have the same thing. A bomb is a collision. There's a momentum before and a momentum after. So we're starting off the same way. You'll notice that almost every question starts this way. Let's consider the bomb. Well, it has a mass originally, and it has a velocity of 0. But after, what happens to it? Well, it breaks apart into 4 pieces. So there's going to be one piece with its own velocity, another piece with its own velocity, a third piece with its velocity, and a fourth piece with its velocity after. So 4 pieces, each one with their own momentums. And we can sort of figure out what those masses will be because we know the total mass of the bomb is 20 kilograms. So this just works out to 20, but because a bomb is just sitting there, in this case, it has a velocity of 0. On a test one year, I gave a question where the bomb was actually moving. And the only difference is this 0 was a 4 or a 7 or some number, and it threw a lot of people off. So if your bomb is stationary, the V is 0, but if your bomb is moving, just put a number in there. It's still going to work out. Okay? Now, what do we know? Well, we know some information here. Now, this is going to get a little hairy, and I'm probably going to have to write this over 2 lines. So we have the first piece, 7 kilograms, and its velocity is 10 meters per second, but it has a direction of 0 degrees. you can see what's going to happen here. Not only do we have 4 pieces to deal with, but they're moving in 2 dimensions, which means all of our additions and subtractions will have to be vector additions and vector subtractions. So there's going to be some triangles here. Okay, now the next piece is a 4 kilogram piece, and its velocity is 14, but with a direction, and that direction is 270. Then I have 2 more pieces, which I'll have to go down underneath here because I don't have room. The next piece is a 3 kilogram piece whose velocity is 22, but with a direction of 190 degrees. Right? And then the last piece, well, we can figure out its mass because the total was 20. And over here we see we have 14. We have 7 and 4 and 3. So that's 14. And so if we take that 14 away from the 20, the last piece has to be 6 kilograms. But its velocity is what we're looking for. So there's our unknown. The trick here is how do we get it? Okay. So we need a picture. We've got to add 3 vectors together first before we can do anything. And the way you add 3 vectors together is, of course, by using vector triangles. So this is a little tedious. Sometimes I like to look for shortcuts. If you look at the directions, if you find any directions that are linear, like if this had been a 180 right here on number 3, if it had been a 180 degrees, and you look at the 0 degrees, we could have just combined those two with a plus and minus because they're on the same line. But alas, we cannot. So that's not going to help us. But sometimes you'll find, one goes 90, one goes 270. Well, those are opposite y directions, and you can just simplify them by using plus and minus to figure the sum of those two out, and then just add that sum to your next one in a triangle. All right, we're going to do the triangle. We're going to look at the first 2 here. I'm going to change colors. We're going to add these 2 up first. Okay, so 7 times 10 is 70. We're adding 70 at 0 degrees. That's the momentum. And we're adding 4 times 14, which I think is 56, right? So that's 56 at 270. We have to add those 2 momentum vectors. How do you add them? Tip to tail. So take the first one and draw it this way. 70. And of course we can give ourselves a reference frame so we know what we got there. 70. Then tip to tail, I need a 56. 270 is straight down, right? Remember your 0, 90, 180, 270. And that one's a little shorter, so 56. And we have to figure out the resultant, or the sum of those 2, which is this line right here. And we do that, in this case, because those 270 and 0 are on a 90-degree angle. This is just a simple Pythagorean theorem. All right? So Pythagorean theorem, I just realized I don't have my calculator handy, so we have 70 squared equals 56 squared. Sorry, let's do that again. I'm thinking about how I'm going to do these calculations without my calculator. Okay, so we have c squared, which is the blue, equals 70 squared plus 56 squared. I'll run and get my calculator, so take a breather. I'll be right back. Okay, I'm back. I could have paused the video, but I'm always afraid if I pause it, it'll erase what I've done so far. So, all right. So now, what are we doing here? 70 squared. Well, that one's easy. And 56 squared. So C is equal to the sum of those numbers, and then a square root. So it's going to be 89.6 6, which I can just round up to 90. There, 90. Now don't forget, that's just half. The other half is the direction that goes with that. I need this angle. So tan theta is opposite over hypotenuse. So theta will be 56 divided by 70, and then the inverse tan of that. So it looks like theta is about 39 degrees. So what I've effectively done, if we go back, is I have simply figured out the sum of these first two vectors. I haven't even touched these guys here yet. So I'm just going to replace what's in the blue box with the sum that I've calculated. So my equation becomes, I'll go back to black here, becomes the 0 on the one side. You'll recall that it was a 0 times 20 right there. So 0. And I have this new sum, which is 90, and it has a direction of 39 degrees. Now be careful. Go over here. This is 39, right? But that's not written in standard angle notation. So I have to figure out the angle this way from the x-axis. All my angles are given in the reference frame from the positive x-axis, right? Standard math angles. So I have to do the 360 and take away the 39, which would be, I think, 321, right? So the actual direction of that is 321 degrees. It's not 39. You've got to go back to your picture and put it in the proper reference frame. Now what's left? What's left is the rest of this from before. 66, 3 times 22 will give us 66 at 190. So I'm adding 66 at 190. And then I'm adding the plus 6 V4 prime. Okay, so guess what you have to do now? You've got to do another triangle. Now I'm not going to do it. It's an assignment. You can do it. I'm going to get you to add these two tip to tail, just like before. And then when you're done, you're going to have a sum of those two right here, whatever answer you get. And it's going to have a direction, right? So I'm going to give it a fake direction just to see what it comes out to. I can guess if I look at the picture, if I take that blue arrow and I add a 190 degree to it, I'm going to guess that I'm going to get about, I don't know, 250 degrees. Let's say that's the answer I got, just to show you how to go about it. How do you solve this? Well, the same way you would any other. You have to move this to the other side. Well, how do you move an angle to the other side? I'm going to show you. You take your angle, right, which on this graph, 250 would be about here, right? 250. All you do is reverse it in the opposite direction, because when you move it to the other side, it becomes negative, right? And of course, that means go backwards, go the other way. So we have to simply take this and make it go this way. And how do you do that? You simply take away 180 degrees from the angle that you have. Or you can add 180, it's either way, it doesn't matter. In this case, it makes more sense to take it away, right? Because then we can do one. Usually if the angle is larger than 180, like ours is, then you subtract 180. If it's bigger than 180, or smaller than 180, sorry, you add 180. But it's a 180 degree shift. So what we have to do is we have to take that 250, move it to the other side, and so it'll become this. And its new direction will be 250, and we're going to take away the 180. Now be careful. Taking away the 180 is the equivalent of making it negative. So you don't make it negative and take away the 180. Okay? You put 70 degrees here, and that takes care of the negative. So there's no minus sign when we're doing this. We're simply reversing the direction using vector language rather than minus signs. And that's going to leave me with my 6 V4. And then, to get the V4 prime, you just divide both sides by 6. And when you divide a vector by a scalar of 6, all you have to do is divide this part. The 70 remains unchanged because there's no angle in the 6 to affect it. So go back to here, finish this addition to get your to here, and see if you can't get that through all the way to the end. Very sticky. Okay.